there, the base angle theorem and the converse of it. But for what's going to go on with the problems today, it's not that big a deal that you remember like exactly by word what they are. Like I'll show you how they're going to be applied. That's what you need to remember. Once we go through this stuff today, you'll see that some of the problems you would have done in the past couple of days with triangles being congruent, you could have done it a different way. Okay, this just gives you one more thing to work with. All right, so the first thing, and if you look up there right now, it says you're basically dealing with two types of triangles, isosceles and equilateral. All right? So as this goes, remember isosceles triangles, triangles that have two congruent sides. The side that's not a congruent side is called the base. Now, you have to get out of your mind right now that base means it's on the bottom, because isosceles triangles can be facing any way. All right? It doesn't matter if it's this direction, which is easiest for people to remember because they go, that's the bottom, that's the base. These two are called, the congruent ones are called legs. All right? But even if it was turned sideways or diagonally or whatever, I mean, if it was that way, and these were the congruent sides, that would still be the base. All right? Not that one. The non-congruent side is the one that's the base. These would be the legs and the base. Now, the reason that gets brought up right now is because the theorem is called the base angles theorem, which means you have to know where the base angle is. Okay? So if I label this triangle, just, I don't know, A, B, and C. So if I label that A, B, and C, out of those three angles, which two do you think would be the base angles? B and C. Those are the ones that are on the base. All right? So that's going to be the first key thing you have to kind of know in order to get this theorem down. All right? And I just kind of marked off what the property is anyway. Okay, so B and C are base angles. All right? The other one is called the vertex angle, but it's probably not going to be referenced by that a lot. Most of the stuff is going to revolve around you guys identifying base angles and moving on. Now, the way the theorem goes, the base angle theorem basically says the base angles are congruent. That's it. If you have an isosceles triangle, those angles are congruent. For the purpose of doing the problems, guys, like everything is going to revolve around you being able to identify where those angles are because they're equal to each other. You know, along with the fact that all the angles in a triangle, the interior ones are still going to add up to 180. Easiest way to identify them is if you just go to the congruent side and draw arrows to the angle that's opposite it. Those arrows are always going to point to the angles that are congruent to each other. So even if it's turned upside down and you've got like multiple lines in there, if I said those are congruent sides, those right there would be your congruent angles. Okay? When the triangle's by itself, it's not necessarily a difficult thing to recognize where those angles are. It's just if they start throwing other lines in there, or stacked triangles on top of each other, then it becomes, you know, a helpful tool to be able to draw those lines in the right angle, or the arrows. Right now, so I got that. But guys, the basic thing is, if you just write down base angles theorem says the base angles of an isosceles triangle are congruent, you have the whole theorem down. And what this does, this just gives you one more pair of angles that are congruent. Which there are problems that we would have done. Like even on the warm-up, there was one problem that had an isosceles triangle. It just had a line going down this way. And I think on the warm-up it ended with side, side, side. If we had already done this theorem, you could have also done the side angle triangle. Just add one more thing that you can use, you know, to the theorem list that you have. So this isn't, for the triangle congruency proofs, this is not a necessary tool. It's just in addition to everything that we already have. Okay? All right, so that's the first thing. Because pretty much everything today is going to be focused on finding the measures of angles. I'm not worried about that. All right, second thing is the equilateral triangle. Okay, so equilateral triangle, 3 congruent sides.
That's wrong.
All right, and if I gave you this triangle and I said, look, all the sides are congruent, an equilateral triangle, could you probably come up with some properties about these 3 angles? Like if all the sides are the same, what do you think has to happen with all these 3 angles? They have to be the same. So, if I know this to be true though, if I said, look, all of these angles are congruent to each other, which is a true fact, right? Equilateral triangle, all the sides and all the angles are the same. If I asked you to find the measure of those angles, based solely on what's up there right now, could you do that? Like, can you tell me the degree measure for each one of those? 60. All right, how'd you get 60? Just do one.
180 divided by 3.
Yeah, so the triangle equals 180. 180 divided by 3 would give you the 60. All right, so for the problems today, the 2 main things you got to remember, outside of the fact that the interior angle add up to 180, so you know that. But you're going to be working with equilateral triangles and isosceles triangles kind of stacked with them. So equilateral triangles, you got to remember, are always going to have 60-degree angles. Isosceles are just going to have 2 congruent angles. Okay, and there's going to be one other thing I'll point out with the whole isosceles part here in a second, because the rest of this stuff is all going to be examples, guys. So that's it for like new kind of stuff. It's kind of a break from what you've been doing, not as involved as the other stuff. Okay? All right, so, all right, these are the first 3 I'm going to do. I'm going to do probably about 5 examples before you guys do some classwork problems. Okay, now the key to doing these is to identify which kind of triangle you're dealing with. Like, is an isosceles triangle there? Is there an equilateral one? That kind of thing. Because those are the properties that go with them. You know, if you can identify them, that's good. All right, starting with this one over here. That would be an isosceles triangle, the entire thing. Okay? So the first thing I would probably want to do is identify which angles are congruent. And I say you can do that by just drawing an arrow from the sides that are marked congruent. So these 2 are marked congruent. So I know those 2 are equal. So that means if this is 52, this one up here is also 3. Okay? Now, the reason you would want to do that here is if I know both those are 52, I can figure out what that entire angle is up there, correct?
76.
104, and you subtract that from 180, right?
Yeah.
So 180 minus 104 would be 76. So I know that entire thing is 76. Now, these 2 angles are marked equal, correct?
Yeah.
76 divided by 2 would get you 30, 80. So I know right now I got x equals 38. Okay? Now, here's the other thing that's going on. If you ever see a drawing like this, right? It's basically, guys, you've got an isosceles triangle, and you've got a line going down it like this. That is an angle bisector. All right? If all that happens, the only way it's possible to draw a vertex angle, right? That's the vertex angle that's bisected, is if these 2 are congruent. Okay? So if you ever see this, these 2 parts are always going to be equal. So if I've got 4 there, right here I have 4. No special meaning. Okay? So like, there are going to be theorems in the next chapter that back this up.
What would be the answer? 4 degrees?
4. Segment length is 4. You want to put feet with it? It's 4 feet.
Oh, okay, I got it.
All right?
Yeah.
Now we're good to go. 4 feet.
So we're solving for the variable?
That would be the problem.
Okay.
Oh, yeah.
I don't know what we're trying to find. Why couldn't we just write 4 and 4 at the I had no clue what we were trying to find. I was like,
I would hope if you see a problem like this tonight, you would do that. You don't need the expert.
Okay.
All right, next one here, second one.
Equilateral triangle?
What kind of triangle is this one right here?
No,
That's a right triangle. Oh, someone said equilateral.
it is isosceles.
It's isosceles, because how many sides are marked and grown?
2.
Which
Which means that's the base.
means this right here is the base,
Uh,
which means
if that was 46.
Those were the same.
So it's 46 plus 46.
is
92. 180 minus 92 is someone figure that out. 88.
Alright, so there's that one. Alright?
Isosceles.
That isosceles.
No,
So are
it's
these two the same?
Yes.
Yeah.
You don't know?
Yeah, and that's still the base, don't it?
So it's, 180 minus 40.
Wait, let me write what you're saying. You're saying 180 minus 40.
40 divided by 2, you get the.
I thought it was. I just slow down. It's
Oh, yeah.
hard. So I have to write.
Alright, the reason we did this, right? I knew that if I do 180 minus
I know, me
40,
too.
I get how many degrees would be left over between these two. And since it's isosceles, x and y have to be the same because they're the base angles. You just take that leftover and cut it in half. 140 divided by 2.
Oh, yeah.
Okay? Alright, so these are very straightforward problems. There aren't too many things stacked. Okay. Not going to do this one. We're just going to scratch that.
So those over there aren't even here.
Alright. There's 2 triangles there. One here, one there. What kind of triangle is this one up here?
Equilateral.
Equilateral because all the angles are the same. Okay, so that means that that's 56.
And doesn't that line? But they're not all.
What kind of triangle is this?
Isosceles.
It's isosceles because they only mark 2 angles.
The one on the bottom.
So these are my base angles, which if I draw arrows from them, will point to the one side.
So.
8x equals 56, x. Okay.
Oh.
Very
Are we research that now? I just said it.
Oh, okay, now I see.
All right, 2 or 3?
Do 3.
Three?
Triangle.
And then I just saw that 8x.
All right, so here's the thing on 3. Here's the thing on 3, okay? You gotta kind of focus on each triangle separately. Like the one I'm gonna work with the one that has the 60 in it first. Okay? Now, based on what is drawn in there and what I know so far in terms of theorems and stuff, the only thing I can get from this triangle is the fact that I've got 2 sides marked and grown in it, which means it's isosceles. Okay? Yeah, but that's inside. I don't care about it. All right? So I can, because it's isosceles, I can just draw my lines to my base angle. That arrow points to 60. That one points to x.
That's 60.
That's also
120.
60. Okay? Which means, which also would mean, like, if that's 60, right? Would this entire angle here also be 60?
Yeah.
I'm not getting
Ooh, so
easy.
that means you cut it in half and then
So what's
60 plus 30 minus 180. Well, 180 minus that. And that would be y. 180 minus 120. Yes, that would be y. 180 minus
So
120. Because the whole angle right there is 60. So
Shouldn't
cut
that
it in
be
half.
I wouldn't even
That
mind.
An
All right, all right.
equilateral.
Now you're
the
saying,
angle
wait, let me do this. Next thing, just forget that part.
Whoa. Yep, that's gonna be exactly what I just said.
Okay. The next thing you would have to do is focus on this triangle. Again, it's isosceles, correct?
Yeah.
So if I draw the lines from them, that one goes to that angle, right? That's why. So look, I've got it. If if I do all the angles added together, I would get y
Yeah, that's it.
plus y plus this entire angle.
Oh,
So there's
It's the measure of this entire angle. What do you think?
120.
Yeah, 120 because that's 60, that's 60.
tell me no, that's exactly what's off.
I know, she got it right. 120, or 2y plus 120 equals 180, 2y equals 60.
I'm so bad. You're like, no, you're wrong.
I feel like I got
Your
that.
answer though.
Yeah,
That's 90.
You're right.
Take my edit.
I'm just changing my answer 6 times.
All right, guys, all the answers are up there. They're all correct. Okay. So looking through it, guys, right? 5, she had x is 65, y is 50. 6, you got x is 45, y is 90. 7, x is 55, y is 70. 8, you got x is 30, y is 20. 9, x was 70, y was 20, and then 10, they were both 45.
Yeah.
All right, that's the